So yeah, if you need to do these labs and you're having any trouble, let me know. I can just respond to you one-on-one, or I can include I can do one or two of these questions in class in the next session if you let me know. And worst case, if you still need help, I can even schedule an office hours. Okay, so we can actually set up a separate session. Although I know that you're so busy, so if I do a separate session, I don't know how many of you are going to turn up. But I say all this only to prove the point that I'm here to help you. Okay, so if you need any help, let me know, and then we just have to figure out how to make it work. Okay, so yes, so click on the lab. It should open up. You should have a place to write code. So let me just open it and show it to you. You have a place to write code. So if you click on it, you can go in here and write code. Let me just review this one more time for all of you. The instructions for the lab are on this page, right? So it tells you what to do. And then, yes, it requires you to sign in. So just can you create a sign in, a code board sign in? It doesn't require a sign in always, but I'm not 100% sure. So can you just pass in an email and create your own login? Okay. So that way, what happens is then you can save your code and come back to it later and all kinds of extra features when you sign it. Okay. So if you need an extra login, I apologize. I'm not able to get everybody to share the same login. So please create a login on Codeboard. Okay. So right now you would have then 3 logins, right? For this course, you have one to the course website, you have one for the cloud hosted Jupyter notebooks, and one for Codeboard. And for those of you who are asking the obvious question, why do I need to do code in Codeboard? The only reason is because this code I have set it up so it can automatically give you feedback when you write the code. So let me talk about that. When you write code, if you hit the run button, it will run your code. Okay. So if you hit run, it will run your code. Then there are a bunch of tests. So what I've really done is I've actually created tests to test your code and put it in this file here. So if you run test, it will test the code that you've written against these tests. So you can also read, for those who know Python, you should also read these tests and understand what they're doing, okay? And then once you pass all the tests and your code is looking good, then you just hit the submit button and automatically it will submit everything and you will get your grades, okay? And when you get your grades, you will see it back on this page, you see. I'm sorry that it says 1 point possible, it's actually 100 points, okay? It's scaled by 100. It just doesn't show up on the screen here. So if you get 0.7, it means you got 70%. Okay. So when you hit submit, your grades will automatically show up here. In order to see the grades here, you must reload this page. Okay, a lot of instructions. If you have any trouble, let me know. Okay. But what is most important is not the grades, is not all this. What is most important is that you start writing this code, right? So please spend some time, maybe in the next class, we can talk more about it. If any of you reach out to me, I can even schedule some time during the class to do a couple of these exercises together. Even now you can tell me in chat if that is helpful. Okay, so a couple of interesting things for you to do. And with that said, can I switch gears and we start the session for today? Any questions? I have 10 seconds for you if you have questions. Okay, one more thing. I don't know how helpful it is, but after every session, in this section called live lecture, there is kind of a video recording of what we discussed in class. So if you want to review something or first, you can just follow up from here as well. Okay, so today's work for us is to go and look into pandas. Clearly one of the most important things. I did some build up to this when we did NumPy, right? So let me just start talking about pandas. So what is the idea? So the idea is that underlying Python, we would love to get slightly more efficient code and more handle on manipulating things easily. We already saw this with NumPy, and now Pandas comes along and says, I will wrap NumPy up and give you a lot more data manipulation capabilities, right? So you will have lots of ways to manipulate the data. I won't say much right now. Let's just go write some code and see what happens. But quickly, can we take these 2 polls? Just so I know and I can imagine what you're doing. During the live session, do you use the notebooks to write code, or do you just listen to me and watch me? And also, I certainly write code. And also, have you used Pandas before? So can you just submit and let me see what you're saying. Okay, so most of you write code. That's awesome. Some of you have, okay, some of you have not used Pandas at all. So this is good, okay? So for those who have used Pandas, just look ahead, okay? It doesn't matter, just think about questions you have. And of course, the notebooks will make it easy for you to write some code, right? So we can keep going. So what you need to do is go to this section, 3.21, which says interactive session. And there's a notebook there for you. So click on this notebook, it will bring you to the website, and then just, okay, so let me just click on that. It'll bring you to this website. Click on login, then hit clone, and then hit the run on free compute button. Okay, so you have 3 buttons to click: login, clone, and run on free compute. Okay, if all that is successful, you should see something which looks like this. Can one of you tell me if you get this far? Anyone? I started this early for some who came a few minutes early. Okay, at least Frank is there. One more person. Let's see. Two means everyone is there, or 3 means everyone is there. One more person who's able to get this far. Okay, at least 2. Okay, so that's good. So we have liftoff. Okay, so the others just go ahead and try to get there. And now I'm going to start this session by going to this notebook. So here, if you look in here, you see there's this notebook which says Intro to Pandas. Let's just go to this notebook. Okay. So important thing is for us to start writing code. Can all of you hit Shift Enter on this first cell? It's going to bring in a bunch of imports. Let me just talk to those imports quickly. The first import is NumPy. The second import is Pandas, which is what we're going to focus on. The third import is something I've been doing historically. We can actually get rid of it, but it actually brings in a bunch of defaults for plotting. Okay, so it's customizing. So this is the library matplotlib. .pyplot is the library that I will start throwing in a little bit of graphs as we go along, but we will spend an entire session focused on visualization, right? So anyway, when you bring in matplotlib, Seaborn sets up a lot of defaults, which makes the graphs pretty and so on. It's not required, but for now, let's just do it, okay? So please hit Shift Enter. It takes a little while somehow in the cloud for this to happen because it has to initialize these libraries. Do let me know if it, after, I don't know, about a minute, it doesn't finish, okay? The sign that it finishes, of course, is that you will see the number 1 here. Maybe it comes in with the number 1. Yeah, it'll go to star when you hit Shift Enter, which means it's running. And then when it finishes, it will show the number 1, okay? Okay, so let's get started. I think there's a pattern here that I want all of you to, I think I recommend this pattern. Maybe it makes it easier when we see all these new data structures. When you see a new data structure, so Pandas is a data structure. The first thing we want to ask is, how can I create this? How can I create instances of data structures? Right, so simple creational patterns. Usually complex data structures will have multiple ways to create them. Okay, so let's go ahead and start. So actually this particular session is laid out to answer a bunch of common sense or natural questions that we might ask every time we encounter a data structure. Okay, but let's use it in the context of Pandas and see how it works for us. While I'm discussing, if any of you have questions or comments, just put that in chat, okay? Okay, so the first thing that we can do is that if you have a bunch of lists, so now I have to, let's just do it and then talk about this a little bit. So let's say I have 3 lists and I want to create a data structure where these 3 lists show up as columns in my data structure, right? So right now, the data structure I'm thinking of is actually an array. And Pandas has multiple data structures in it. Just to give you 2 names, this is called a data frame. There is another data structure called a series. Series is 1-dimensional, okay? Data frame is, at least for now, let's say it's 2-dimensional, okay? So I decided that for today, I would try with all of you to go straight to a data frame. Then we will go backwards and look at series, okay? Because the data frame is general enough, and I think many of you really want to try to understand this and use this. So let's go straight to the data frame and come back to series, okay? We'll try it out and you let me know either if you have questions or if this approach works, okay? Because normally I would do series first. But let's try. So now we have three lists. And in order to create a data frame, Pandas has been imported with this PD namespace. So pd.dataframe is our workhorse for today. Every time we will be doing a lot of pd.dataframe. And data frame takes a list of lists. So let me repeat that again. It doesn't look so visually because A, B, C have been made into variables, but actually what is passed to the data frame is a list of lists. So let's just shift enter into it and you'll see that a data frame has been created. So again, once we look at this output, we immediately recognize the data frame is a two-dimensional structure, rows and columns, obviously, and the columns are the lists that I specified. Okay. So actually, no, the rows are the lists that I specified. Okay. So there'll be all this kind of stuff that we have to look at in detail. Okay. So just making this interactive makes it easy for you to look at it and play with it. Okay. Okay. Slowly, I will build this up. So the important thing is not only is it a two-dimensional structure, but it's actually indexed. So this is the first feature that Pandas has added, right? Normally, if I want to play with a two-dimensional structure, the only thing I have is integer index, right? That's what we had with NumPy. So to access something, you have to say 1, 1. But now Pandas actually builds two indexes. Okay, so what do I mean when I say two indexes? Pandas actually builds for you. So let's run this right now. It's not very interesting. You just see that there is an index which basically indexes all the rows. And there's another index which is suggestively called columns, which indexes all the columns. And right now, because we have not done any extra information, we have not given any extra information to Pandas, what it does is it by default says, okay, the rows will be labeled with integers, and the columns will be labeled with integers. At this point, the index is not doing much work, okay? But immediately we will come and say, okay, can we do more? So the first thing we can do here, so I'm going to show you a little bit of Python tricks here. If it goes too fast, just let me know, okay? So the idea is I need to create a list with multiple characters in it, right? I want to create, so let me just show you this. You want to create a list which looks like this, A, okay, so to make this list, let me do it painfully. You have to put quotes for A so that it's a character. Then B, I'll stop with B. Okay. Okay, so you want to create a list like this. There's a very clever way to do it. You make a string like that, which contains all the characters you want in your list. And then you call this thing, which is a list constructor. It creates lists. So if you call this thing, then C will actually contain a list. So let's just check that out quickly for those who haven't used this construction. If you look at C, see that it has the list. Okay, so you can see quickly why if I want to create a list with all the alphabets in it, it would take me a long time to put all these quotes and commas and everything in place. I could just type A to Z quickly in a string and then create my list. Okay, just a shortcut. But of course, code is all about knowing and using these shortcuts wherever you can, right? Save yourself some time. Okay, so what have we done here? So now we're going to repeat creating that data frame. But now we're going to say, can you please use the columns from this list, right? So here, here the columns are specified from this list C, okay? Okay, so the columns are specified from this list and the rows are specified from another list, okay? So actually here, so what have I done? Okay, so let's just run it and see what happens, okay? So I don't know if this is, so it should be df1 here. By the way, it's a convention in this world to call every data frame df of some kind. Tells you it's a data frame. I use this df1, 2, 3, 4, 5, 6 as because I'm not naming them yet. Okay, they're just simple things for us to play with. So anyway, if we run this, then we look at the data frame. You see now where the indexes were integer indexes before. Now you have actually labeled indices. Okay, now because I don't have much imagination right now, I just use single characters. But depending on which problem you're solving, these column indices, for example, usually can have some sensible meaning. Very often the row indexes might become like time if you're working with time series and so on, right? So carefully choosing the right index and columns will make your code much more sensitive to your domain and easy for you to manipulate. So now let's go and look at this object again. So now if you look at the index object, you see the index actually contains the values that I gave it. Okay, and the columns of course have names. Okay, so quick thing for you, can you take a minute and try this out? Okay, I made it a little harder now, but I've created a dictionary. Okay, for those who are not familiar with Python data structures, I will just say one comment here. If you need help again, just reach out to me. If you don't, I'm happy that you know all this stuff. Python, I'm using two data structures from basic Python. One is a dictionary and the other is a list, right? So here's a dictionary, but this dictionary has some data in it. The keys are population and area, and the lists that are the dictionary is the key is a string and the value is a list. Okay, so it's a dictionary of lists with keys who are strings, population and area. And then I have another list here, which is the names of these cities, right? These, so then I want to create a data frame here, but I want to create it out of a dictionary. Now, there is a principle I talk about in programming, which you could call the principle of least surprise. If it works, it's great for us. So let us see if we can find our way. What I mean is, if we do what seems natural, we should find our way to write the code, right? If it's complicated, then the least surprise is not manifested. So let's see. The way to write this code obviously would be, okay, I know I need to do pd.dataFrame. Then I have to pass, basically I have to pass the data. So you pass the data, and then I would like to choose an index. So I say index equals, and the index would be the names of the cities. Okay, I don't know. Is that sound like least surprise to us? Let's see what happens. Data is not defined. Okay, so that's because I didn't run this. By the way, this is when problems happen, it's really cool because I get to show you things that you might see. So here's what happened. The notebook actually should be run from top to bottom. While I was talking to you, I skipped over this cell and I ran this cell first without running this cell. How do I know that? You look at this number here, it says 8 and this number says 9. So clearly this was before that or whatever. So this is completely out of sync with what I'm doing. So I have to go back and just run this cell, okay? And hopefully now we should be good. Okay, we have done this, but how do I know what's in cities data? So you can either create a new cell or you can put it at the bottom of the cell. So let's just do it at the bottom of the cell. And look at it. Let's see what it has done. Okay, it's done something that starts to look nice, doesn't it? Because the row index is the name of the city, right? And the column index, the names of the columns start to become meaningful, right? It says population and area, okay? So I think we have liftoff in some sense. This becomes a template for you to do all your work, right? Initialize your data frame. Right now I've shown you two ways to initialize it. One is from a set of lists, another is from a dictionary, and then set up an index and column names as required. Once you've set them up, you can always retrieve them back by asking for the index and the column names. Notice you don't have to say column names, you just say columns. And then the actual values, you can access them by saying dot values. Notice that when I say dot values here, what actually comes back to me is something which should be familiar to us from last class. This is actually the Numpy array, right? So under the covers, this is the reason why we talked about NumPy before we went into Pandas, right? Under the covers, it's using NumPy. So there are many moments when you can actually extract the values and manipulate them directly in NumPy for flexibility or performance reasons. Although I'm going to show you today that Pandas gives you plenty of stuff to manipulate the data. Okay, so far so good. Now if somebody's wondering, okay, why do I have to do all this? Let's start down some path. I'm not sure what is the best path, but I will just make this statement to you. The Pandas library has a tremendous amount of abilities, capabilities, can be mildly overwhelming. It's more complicated, I think, today to learn Pandas than to learn Python, okay? But I don't know, it's at least of the same degree of difficulty. What I would say to you is that there's a Pandas documentation link here. Definitely go and browse whenever you need. You'll find it very useful. Pandas was created originally by Wes McKinney, and Wes McKinney has a book which is quite readable. It is big and heavy, so of course there's lots of material in there. I think it's always good to go to the source for these things. So I would recommend that book definitely, right? So if you want to get hold of it, that's a good place to go. Okay. So what else? So now let's just go and look at what can I do now that I've created my data frame. So once we have created the data frame, the index itself is a very useful thing. So let me show you something interesting. So I create another second data frame. Okay. So let's go ahead and create the second data frame. Take a look carefully and see what I changed, right? Actually, what I changed is I only changed the index, right? Instead of ABC in the previous case, I said ABX. So if we actually look at this, so let's look at DF2 if you want. Just since we haven't looked at DF2. So if you look at DF2, you see that it has an X for the last row, okay? So now immediately I can do something fun like this, right? I can say, let's take both the indices out, one from the previous data frame DF1 and one from this current data frame. And let's ask what is common to both of them. Okay, so if you like, I will put this in a separate cell, okay? Escape B will give you empty cells, okay? B below, okay? By the way, if you need any keyboard shortcuts, if you go to help, you'll see keyboard shortcuts here. At least learn a few, when you need to do something, just look up the shortcut, okay? For now, you can use the menus, but over time, I think it's easier if you can just use the shortcuts, okay? Okay, so let's go look at this. So if you ask Pandas, hey, you got two indices, can you show me what's common between these two indices? Then cheerfully it does it, and it uses the logical AND symbol to do this. Notice A and B are common. Similarly, you can do other logical operations, right? You can say, do a union of them. So you can say A or B, and you get a list of 4 elements and so on. Now, you might say, okay, so that's cool. Why do I want to do all these set operations on this index? The answer is you can run an operation which looks like this. So you say df1.reindex, make a new index for me, but now only use the common values. And what it does, if you look at this and you run this code below, you see that it basically gives you only the common rows. Right? So now this becomes a very nice way for us to look at, common intersection values between two data frames and so on. Only tip of the iceberg, but surely we can start here, right? Okay. So another thing you can do with reindex. So we talked about the existence of indexes. Now we're saying, okay, indexes themselves can be manipulated by set operations. Now we can also change the index. This is an interesting operation. So I want to create a new index on this data frame, but notice I've added 2 more values to my index. So if I do reindex now, it expands the database to incorporate the new index. So 2 more rows are created for me, but because there's no data for those rows, they come out blank. So again, it's a nice little metaphor to either expand a data frame or to create a data frame. You can reindex with a list and you will get something. Okay, of course they'll all be nans and then you have to fill it up. Okay. Okay, so much for reindexing. Okay, again, here it's hard for me to tell how deep we can go. Any of these topics, you can spend some time thinking about how you would use it. I think it's okay for you to say, you know what, I'm not going to, this is how I process as well. I'm not going to be reindexing my data frames. I'll just create them and use them. And that's a good place to start. I just want to show you these things as we go along. At any rate, I want you to appreciate that there's a lot of stuff we can do by manipulating the index, right? Which we'll normally do. So now again, I have to make one more comment here. So this class, this session is the start of a slightly different journey for all of you. We already saw this when we talked about SQL, right? That when we start manipulating data, the naive thing would be to say, give me if statements and for loops, and I can manipulate the data. But usually that's not very performant. And it's also not very expressive, right? So we switch to writing code using these kind of techniques. Like, for example, do a set operation on the index and then project out the common values. Notice I have completely changed the way I think about the problem and solve it, right? So this will be difficult for you. But once you do this, that's why I said practice is essential, right? Once you start thinking like this and do a little practice, you will be very productive. Because instead of writing complicated code, you would write one-line code like this for reindex on common values, and your data frame will do something cool for you. Okay. So yeah, be selective on what you include in your thought, into your mental patterns or your thought process. but then of course slowly practice and incorporate as much as you can of the available structures. Okay. Um, just my comment here, sometimes when we, for every kind of data there is metadata, and for us as coders, of course there's code, but then once in a way we have to think about how we process the code. Why do we write code like this? How do I think about it? We don't spend enough time thinking about all that stuff or talking about that stuff. So I try to share my comments periodically with all of you to save you some trouble later, or to give you some view of the landscape. Okay. But if it is distracting, let me know. I can reduce it or increase it based on your comments. Okay, so let's keep going on. So now, once you create a data frame, this is a very go-to method we will use. It's called info. By the way, for those who have used R, there are a lot of synergies, right? There are many things here that have overlap with data frames in R, which is a good thing. So the mental patterns are very similar, just maybe the specific command looks a little different. Okay, so you can do this, right? So you say info, and it tells you as much info as it can about our data frame. So let's take a moment and just read this info one time. Later you will use this a lot. So it tells you, some properties of the index. Then it tells you how many columns are there. It tells you something about the values. In particular, it gives you the counts of the values, and it shows you what are the data types, right? It says population is an int 64, and then area is a float 64. These are the D types we talked about in NumPy earlier. So you can see how that is all getting done. You see it listed as D types here as well. Okay. And now something very useful for those who have to, eventually you'll have to worry about all this. It also shows you what is the memory footprint of this data frame, right? So running info periodically, especially when you start doing a project and you load up, it's amazing. You can load up 1,000,000 rows in a flash like this, right? So it will be important to know that you don't run out of memory on your computer or whatever. Okay, so info is there and describe is there, right? And describe basically gives you descriptive statistics on the columns. So if you want a quick way to do this, then just load up your data and then run a describe and you get started. So it's a good way to do your preliminary data analysis, right? Load up the data, call info, and then run describe. Then at least you're familiar with your data frame. Okay. Okay. So now the next, so much for creational patterns, a little bit about descriptional patterns. Now the next important thing for us with any data structure is to ask the question, how can I access things? Right? If things are stuck inside in data structure, how do I get it out? And of course, the workhorse for many of these things is the index operator or the bracket operator, right? So let's see how we can use the bracket operator. And then there are patterns here that we could use, right? So for example, if you want to select all the columns or select a column, then you could use the bracket operator. So you can see here that, so why don't you try this out as I'm talking about it? You can take any column, single column, or a list of columns. If you have more than one column, you should use a list of columns. Okay, so maybe even if you have one column, you can use just a list of one element. So you put the column names inside the list, and then you use the bracket operator. Notice there are two brackets here that look like the bracket operator, but really it's because the first bracket is the index operator, the second bracket is there because it's a list. This takes a minute to get used to, but okay, after that you'll be doing it without thinking too much. Okay, so you can actually index into your list this way. We'll take a moment and change the entries in your column selector and see, just get only A or B and C or whatever you can play with. Okay, then the next thing you want to do is access by rows. But when it comes to access by rows, we have to say, okay, there is the normal way of doing things and the index way of doing things. Yeah, so sorry, one second. So what is the index way of doing things? The index way of doing things, okay, so let's start with the index way of doing things. You use this operator called lock. Okay, and to use this operator called lock, what you have to do is one second. Okay, so what we do here is you use the lock with some powerful tools here. Okay, in particular, now I'm using lock, which are entries from the index. Notice ABC are entries from the index. I want to get all the elements from A to C. So now I'm riffing on a Python pattern, which is called Python slicing, right? So again, if you want to get familiar with this pattern, please go back to lists and play with slices. If you want to discuss it, come back to me. We can talk about it by email or something. But it's not a pandas concept, right? The concept goes back to raw Python. It simply says if I want a range of elements from a list, then you should use the colon operator and specify the start value and the stop value. Notice there is a subtlety here. I won't focus on it. You should play with it and understand. There is a subtlety in Python as to whether the last value is included or not included. I guess I should have asked it as a quiz question. In Python, often the last value is not included by convention. But notice in Pandas, when I said A to C, it gives me C as well. So that's a little bit of a difference, and you must think about how that affects the logic you use in your code. But having said all that, it's very cool now that I can actually do slicing like I would do with an ordinary Python list. So the Pythonistas love this. You can do slices. For those who are learning it new, this is a little bit unwieldy, I have to admit. When I first saw this, I was like, do I want to do all this? But yes, getting subsets is really important. So not just extracting one row at a time, sometimes getting a whole range of rows is important. So this is one way to do this, right? You create a slice, use the lock operator. The slice itself is parameterized by elements of the index, right? So basically you will get everything you need here. Of course, there's a good old way of accessing stuff by rows, but using integers, right? The first row is the first row, second row, third row. So 1, 2, 3, 4, 5, 6. You have the integer natural index. So again, Panda supports that, but you have to put this I lock here. And I lock basically says integer based on integer locations, right? So now you can slice by integers. So again, this becomes a very big workhorse for you as you go along. If you're working with subsets of data, just get familiar with the lock operations, either index lock, which is kind of funny. So here, I could have been index or integer, but actually I is for integer, okay? So integer lock or index lock, and then you can get subsets, okay? So why don't you try, maybe I'll give you a minute, right? I've been talking a lot. So why don't you try for a second, get the second row from the data frame df1. So I just give this to you to say you should create small little things like this to play with in the beginning. Then when you start working on your project, you will have to do real work. So then you will know exactly how you can proceed, and you can focus on solving the business problem or the project problem rather than learning pandas. Okay, so quickly try. If you don't finish it now, you can finish it later. If you want me to do it, you can tell me, we can do it as well. There's a lot to cover, so I'm going to soldier on, okay? Okay, so now let's continue with slicing. So if you take a data frame and you just specify a slice like this, I've just used a default slice. I haven't even used lock. Panda says slicing is very common in Python. I don't know if you want to do this. I think it's better to use lock everywhere and be clear about which kind of slice you're working with. But Pandas will allow you to use just a slice, and it will default to using row slices, okay? And if you just don't say lock at all, it will always default to working with rows. So if that's a pattern you use a lot and you're looking at row subsets, then you could drop the lock. But it's nice in your mind to know which pattern you're going to use and then use it consistently. Okay, so now lock is actually powerful, right? So for example, if I want to get, so notice how this story becomes very, very low level, right? Manipulating and getting subsets out of this data frame becomes an industry for us, because that's, I don't know what percentage of your code would be like this, but a good percentage would be this way. So df.lock, and now I specify a list of rows and a list of columns. This is the most powerful subsetting operation, right? I explicitly choose some rows by some method, which are rows of interest, and I choose some columns of interest, and I will get the subset, right? So that is powerful. Notice that instead of specifying lists, I can mix slices and lists also, okay? And we go on. So this can be tiring. So I don't know what to do. I hope that telling it to you in a pattern, in a structured way, makes it easy for you to remember this. And I also hope that you will come back to this notebook, delete all the code in there, just read the instruction and try to recreate it. I think if you do this a couple of times, this will all become second nature to you. Okay, so please do that. Okay, let me go on. So you can, as I said here on line 48, you can specify a slice and a list. But what if I want all rows, right? All rows is a common pattern. So you can use colon here. And the colon says, give me all rows. And you could do the same on the column side, right? If you want all columns, you can say, give me all columns. So please play with these patterns. It's kind of mesmerizing. Sometimes there are brackets, sometimes there are no brackets. So please go through this. I'm sure some things will break. Pandas has tried to be very intuitive, but sometimes it is not. The only answer I can give all of you is set up these exercises, run the code, think about it, and get these patterns transferred into your repertoire. Okay, so if you need suddenly to get all rows, you know you're going to use a colon. And if you need a subset of columns, you're going to use a list or a range or whatever, right? So spend some time on these patterns. I don't need to go through every one of them. Okay, so again, same thing. The patterns that I did with index, rows and column name, row index and column. By the way, columns are also an index. So sometimes I will say index. So rows and column indexes, you can also do with integers, right? But now notice I definitely changed log to ilog, and then you can play with indices. Okay, now let's do something a little bit more interesting. Okay, so what is a little bit more interesting is you can actually run numerical operations, right? Comparison operation, for example, against an entire column. So if I say, give me everything from df1 column A, which is less than 1.1, what does it do? It returns a Boolean. Essentially, the Boolean is the result of applying this comparison to every element in df1, right? So you get a Boolean result. Sometimes this result in itself is interesting, but very often it's interesting to say, okay, if I apply this condition, can I use this to get only the elements where this condition is satisfied, right? Where this condition is true. And the answer is yes. The bracket operator can take this entire operation as an argument, right? So this is called Boolean indexing. So let's step back and ask, what is the idea of Boolean indexing? The idea of Boolean indexing is inside the bracket, if you somehow create a Boolean array, one-dimensional array, which has trues and falses in various locations based on some operation, right? If nothing, you could just type true and false randomly, right? But as long as the array has the right dimensions, by which I mean it has the length as the number of rows of this data frame, and you pass it to the bracket operator, then it will only give you the subset of values where the value is true. Okay, fairly complicated story, but at the end of the day, simple. Pass a Boolean array to the bracket operator and you're done. And immediately you can see why this is a very cool operation, right? Because this becomes the filtering operation on your data frame. So it's like the where clause of SQL, right? So this basically says where the values of A are less than 1, give me all those elements. And this is how we encode that at a low level. Takes a little time to get used to, but then once you do it, you'll be doing this all the time. Okay, so we already created this city data. Let me give you a minute. So can you select all the cities with population less than 250,000, right? So this gives you a chance to try this out. So how would we do that? I'll give you a minute. If somebody's finished, let me know. Okay, somebody's done. Good. Do you want to share your code? You can put it in chat. Put your code. It should be one line, right? So put it in chat, and then I'll paste it here, and we can talk about it. Okay, good. Excellent. So let me take it and put it here. So well done. So let me just put it here. We can talk about this. Obviously, let's work from inside out. Cities data. population less than 250,000. That's the inner question, right? So let's just check it out. I'll show you one nice trick here. So cities population less than 250,000. If I just did this, you should get this Boolean array back, right? So only Poughkeepsie is going to come if I do this. But now let me show you a nice little goodie here. Instead of putting the bracket operation and specifying the column name, if you are interested in a single column, you can actually do something like this. So let me just show you this, and you decide if you like this or not. You can say cities.population. Let's see if it works. It's really cool, right? So you actually, what is cool about it is if you don't remember the column names, for example, if you just type population and hit tab, it's going to actually help you find the column name. Okay, cities.population, right? So you can actually get, completion, especially when you're unfamiliar with the data frame. If you put it in quotes, you have to know. Okay, I say all this, but for this magic to work, this will work only if the name of the column does not have spaces in it. Sometimes column names can have spaces in it. If they have spaces in it, this dot will not work. So this is the fine print in Pandas, okay? Sometimes it makes things cool, but sometimes makes it hard. So anyway, choose your pattern again. Do you want to access column names with a dot or not? Or sometimes, when I'm working on big projects, I go to great lengths of trouble to make sure that my column names do not have spaces in them. So then I can use dots cheerfully. But you may not always have that luxury. So some work has to be done if you want to use dot. Anyway, so then you just index, right? Cities data, and then use the index operator, and you're done. So thank you, Frank, for sharing your code, and everybody can run this. And okay, so please work on small examples like this. Once you and even do it 2 or 3 times, then this will all become kind of automatic, and then we can solve bigger problems. Okay. Today is all about this low-level stuff. I'm sorry if it's a little painful, but eventually this will all go away, right? You just know it. Okay, so next thing is, as I said, this I don't have to run so much. I just want to emphasize that if you grab the values, you get Numpy arrays. Then you can manipulate them, use all the techniques we talked about in the last session about Numpy to just manipulate this. And I would not recommend doing this except as a 2 reasons, right? Except as a optimization idea that you can use some powerful technique from Numpy, and or it's very mathematical, your operation. So you want to do transposes and inverses and stuff like that. And at that level, you prefer to directly use Numpy. Okay, so then you can pull out the values and do your operations. Don't have to worry about all the indexes and all that stuff. Okay, and then you can, at the end, to do your report, you can push the data back into a new Pandas data frame and you can proceed. Okay, so this is done. So first we learned about creation. Now we learned about getting access to elements. We talked about accessing by various patterns, essentially getting subsets of the data frame. Now, can I modify the data frame? And the answer is yes. But the patterns to modify the data frame are very similar to access. On the left-hand side, you access the subset, and on the right-hand side, you assign. And that will just modify the data frame. So you can run this code and change the numbers and so on, but this is how you modify or mutate the data frame, okay? Okay, but this is modifying in place, right? Here, I'm not changing the number of rows or columns or anything. I'm just changing the values. So what about if I want to add stuff to the data frame? So I'm going to show you simple ways. This story of adding rows to a data frame can get sophisticated. So let's look at the simplest things. So the simplest things here are like append, right? What does append do? It takes a data frame and appends another data frame to it. And by append, I like to think of it as simply adding at the end, right? Add at the end. So you get just 3 more rows added. I just appended the data frame to itself, okay? So you get basically a new data frame. It does not modify. Let's check. So this is now a concept we have to look at, which is, when I do these operations, do they mutate the original thing, right? And the answer is, in general, I cannot make this as a strong rule, but it's because I don't know. In general, Pandas refrains from mutation until you ask it to do so, right? So it always gives you new things. And I think that's generally a reasonable coding paradigm, right? Because if you mutate it by mistake, you change something, you want to go back to the original, it's impossible to undo. So anyway, so if you really want to modify the data frame, then you can, this is a standard pattern in that case. You could just assign this mutated data frame back. Okay, this is a destructive operation. Do not do until you know this is what you want to do. You can assign the mutated object back to the original label, and then it'll look as though it was modified in place. Okay. Think about that, play with it, see when you need it. Okay. Now, the next operation here is like append. It's called concat. But concat is more powerful. You can take a list of data frames. Okay, so sometimes there is, like, for example, let's say for I have a loop for each student. I want to create some data frame for each student. And then eventually I want to collect all of those data frames into a big structure and say this is the data frame for the whole class. So then I have a for loop and I create many, many data frames. Then this is a standard pattern. Each time in the for loop, you will add each student's data frame into this list and then just call concat once. And it'll just concat all of them and give us a big data frame. Now, this concat, so now again, when we do these operations, there is a concept. It took me a little while to get used to this concept. But of course, once you get used to it, I guess it looks reasonable. But let me share that with you. Whenever we do these operations, we must always ask, in which axis do I want to work? Do I want to concatenate them so that each data frame is added as a new set of rows, one below the other like this? Or do I want to add it side by side as columns, right? And so sometimes you want to add it as columns. And so you can say axis equals 1. With the same concat command, you can specify. So by default, the axis is 0. If you say axis equals 1, you can concatenate by columns. And that's the end of the story there. You have two operations you can do concatenation wise. Either you can append by or concatenate by rows or by columns, and the axis is the keyword. Okay, so why have we done all this? We put stuff in data frames. We can access them using these clever and interesting indices, etc. But of course, the moral of the story, we have already beaten that to death last time, is because we can do vectorized operations. So for example, if we want to add all the elements of column 1 with all the elements of column 2, but row by row, right? So take the first element from column A and the first element from column B and add them together. Then you can just do plus like this and it will do it. Okay, so let's try this. I'll give you 2 minutes, okay? So I think that the cities data set, which we looked at before, has enough information. Where is it? It's somewhere here up. Yeah, has enough information. Sorry. It has enough information for us to calculate the population density, right? It's all the way up somewhere. Okay, so you can find it probably faster than I can get there. Where did I create it? It must be all the way up. Yeah. Okay, here it is. So the cities data frame has the population and the area. So the population density is population divided by area. So can we create a new data frame which has the population density in it? So how about you take a minute and just do that? If anyone's done, let me know on chat. Anyone? So if someone computes this, can you let me know on chat? Okay, well done. Okay, so yeah, let me copy. Thank you for sharing your code. So I will put it here. It's always nice when you share your code so we can put it here and then everyone can see it. So thank you for sharing your code. So let's just look at it. So I think it's Hayden, right? Hayden did something nice here, which is he not only computed the population divided by area, and this is on the next line, of course, but he assigned it back to the data frame, right? And stored it in this new column, right? So when we run this, you're going to see a third column created, which has the density. But this little thing in a metaphor is why we are in Pandas, right? We can do all these operations pretty quick. For those who use Excel and other things, you can see why we can easily compete with those kind of features, right? We can do operations very compactly. But extra space, I don't know. Okay, but yes, yeah, line break, yes. When I pasted it, it had no line break in it, correct. So, okay, so this is good. Please keep up the engagement on chat, okay? And I love that you guys are writing the code along the way. It's not a race to finish first. And don't be embarrassed if you're the guy or the lady who has to post your code on chat. We're just sharing, okay, and having some experience writing all this stuff. If there's anything I can do to amplify your solutions, then I will mention something. Okay, so it's a good way for us to practice rather than me lecturing all the time. We write some code and we discuss it, okay? There's lots to be said when we review or discuss some code that we have written. Okay, my code is all on display, so you guys should, all of you should share your comments about it whenever it's relevant. Okay, so what am I saying here? So this is where we are. We know now how to do interesting operations on our data frame. Okay, so now we need a lot of practice of this. You will get that soon. So let's just convince ourselves quickly that these vectorized operations are fast. I don't necessarily have to run this and show you, although it would be cool for me to show off how fast these operations are, but just run it yourself, okay? But I'll just mention, just to show you this, you should do this kind of work periodically. So what I've done here is I've created a size variable, and you can very quickly change the size to 1,000,000 or whatever, and you can quickly create large data frames. Periodically, just to convince yourself that this thing all actually works as promised, as advertised, and that it's fast and efficient. Make large data frames and play with it. You cannot break anything. Worst case, your kernel will crash. Okay, so go to million or billion and convince yourself that working with 1 billion rows is not very time consuming. I think it's very powerful. If you want me to demo it, I will, but since it is an interesting thing to do, I hope that's interesting enough for you to try to do. And I've shown you here quickly, there's some comparisons that you can do, right? You can do the operations explicitly using the vectorized operations, or you can do it with a for loop. And if you do the for loop and you make it bigger and bigger, you'll start to see the for loop. Actually, the Python's for loop is pretty good, okay? So you might learn something by staring at these things, okay? When I ran it, you could see there was a big discrepancy between the two. See if you get that much of speed up or not, okay? But it's a factor of 1,000 in some cases. Okay, so even if you get a factor of 10 in these operations, notice when we are doing performance analysis, if something is 10 times faster, it's the difference between 1 hour and 10 hours, right? So that's a huge difference for us, or between 10 minutes and an hour, right? So it's a huge difference for us in interactive code when things take time. Okay. So now we can do a very powerful thing. I'm going to show you a little bit of it. This is actually kind of a finished example for you. So what am I doing? Remember in the first session, we did build a database and we populated the database using SQL, etc. So now what I'm going to show you is that we can do that story, but repeat it with data frames. Right? And you should write code this way and that way and understand what is better and etc. Right? But what I'm going to show you now is, so I wrote this execute SQL command. Please spend a moment analyzing this command if you need. But what is important for you to note for now is that I have written it so that this command actually makes a data frame and returns it to me. I've done some mildly clever things to construct. So you should abstractly ask this question that if I run an arbitrary, so notice suddenly I switch gears and do something. Hopefully you think it's powerful in programming, okay? But recognizing the moment when we want to do this will make your life very cool. So what have I done? I've said, first of all, I've written this function. Let's look at this function as an example of something I would find very useful. You can tell me. So this code basically says, give me any arbitrary SQL, right, that can run on an arbitrary database. As long as I have the path to the database and the SQL, then I can connect to the database. I can execute the query. So by using the stuff we learned about in the first session, then I can get all the rows and I can pass the rows to the data frame. So they will become rows of the data frame. And I can create all the columns of my data frame to be the columns in the table. And so if you run this query, then we are going to get back a beautiful looking table, which has, a structure which is very similar to the table of SQL. What is the difference now? The difference is this table which you're seeing on the screen is a data frame. It's in memory, right? The other one is technically in a database, which can be on a database server or whatever. Because we are running a SQLite, it is also in memory locally on my machine. But this is nice because now I can use all my Pandas tools to manipulate my database data. So this becomes a big subject for us. How can we manipulate database data in different ways? I think the Pandas way is also nice. Okay, so let's do a simple example here. I will get the students from the students table. I'll get all the courses from the courses table. Okay, and then you can start joining them. Okay, you can, so these are all multiple tables. I'm just going to talk to this code because there's an important code here. So this is where the joins happen. And to join data, so this is nothing to do with the database. Okay, I want to reiterate, it's nothing to do with the database. If you have two data frames, then Panda says, okay, maybe you would like to join them. So I can help you join them, right? And to join them, you have the option of joining them on a specific column. This column is usually meant to be the key between these two tables. So then this query, this merge query, looks exactly like the SQL join query, right? It takes table 1 and table 2, and it says this is the join key, right? So ID student in df1 should be equal to ID student in df2. So it's a common, the column name is also common. Okay, now you might say, okay, well, in SQL, there's outer join, inner join, left join, etc. I'm not going to dive into that too deep, but I'll just show you right now. There is an extra keyword here. It's called how. So you say how equals, and then here you can say as a string, you can say inner, outer, left, right. Okay, so this is important. And again, it's not a theory lecture. You should just try to join things and see what happens. Okay, now there's one more concept here. The columns on the left hand side and the right hand side don't have to have the same name, right? In a database, the primary key and the foreign key columns will typically have the same names. Nice to have the same names at least. Okay, but anyway, if the names are not the same, you just say left on and specify the column on the left side, right on and specify the column on the right side. By right side and left side, I mean this is the left table, left data frame and the right data frame. Okay, so you can join. So let's review. You can join two data frames on any column. Let's work with one column for now. Then you can ask, can I join on multiple columns? Okay, on any column. You can specify the column names using on if it's common name or left on, right on if it's not the same name on both data frames. And then you can do, using the how keyword, you can do left join, right join, inner join, outer join. Okay, so that's fairly flexible. The only different concept, and maybe that's a little bit too detailed for you right now, so let's revisit it next class. Suppose this was not a column but was actually an index already on the table, and I want to join by index, then you can do that as well. Okay, so you can say left index, right index, and so on. So let's defer the discussion about joining by index because it's easier to visualize in your head at least and play with joining by columns. So what is nice here, and I don't need to run through everything here, what is nice here is that you have in this cloud solution, the whole database which we created last time. Notice how I'm trying to build for you some quasi-realistic looking application, and I'm also trying to build from each class to the next. And it's a good reason why you should practice a little bit more. And if you already understand the whole structure of the database from the first session, now you can easily manipulate this with Pandas. And this will give you much more power in Pandas when you do this. So I leave this topic for you with one important, let me do one more thing here, just so you know. So you can actually do this thing called group by. A group by is a very powerful operation. So today I will just introduce you to group by. We have one more session to talk a lot more about Pandas. Okay, so we will dive into group by a little bit more. Grouping and pivoting becomes a very key functionality for us. But for now, you can just understand that there is a group by concept, and group by takes for now, let's say at least one column. You can group by multiple columns as well, but let's start with one column. And then you can apply some kind of aggregate function. So for example, here, if I want to group by the course name and find how many students are there in each course, it's just one line. Okay, I showed this one line just to place it in your attention, to also show you that this can get very powerful. But as these powerful pieces of code are written, notice how very cryptic and terse it is. And it's a very special, this is my message for you today, right? This is a very special style of programming. You have to know these operations like group by. You have to understand how to apply them to your situation and then be very conversant with it, right? So it's not enough to know Python now, you have to know group by, right? And you have to know that there's an aggregate function called size and so on and so forth. The way to do this, of course, is to try to write some code. That's why I've given you plenty of examples of code to write. The second way to do this is to look up the documentation of Pandas regularly. The third way to do this is, of course, I think all of you probably do this. You can, of course, search on the net. Just only thing I would say to all of you is when you go to search on the net, please start a stopwatch and don't go down the link hole. Okay, you can get lost when you take a question like this, and sometimes you may come back in 2 minutes or it might take 15 minutes. I know all of you have less time available, so please monitor where your time goes. If you find something very difficult, I would say after spending a few minutes on the web and you're still stuck, please send me a note. Okay, I'm here to help and I would be very happy to save you some time. Okay, so here's a simple thing for you to do. Try to do these two exercises. Okay, and if you really want, again, only if you ask you will get. So if you want me to do this, then we can do this together next class. Okay, but you should try to do this on your own. So now, having said all this, let's just go forward. We have a few more minutes. Good. So there are a few more things I want to share with you. So I don't know, but I hope all of you can do this. Okay, it's fairly easy to do these computations. So please take a few minutes. What I expect is the following. I expect you to not be able to see the answer right away. I expect you to feel a little frustration when the obvious things don't work. But I don't expect you to fail and lose against those frustrations. Okay, I want you to succeed and come through on the other side. That's the discomfort of learning something new. So please challenge yourself and come out on the other side. I want all of you, I believe all of you can be victorious. So if it's still too challenging, come to me and I will definitely help you with some hints or suggestions, and then you will be victorious. Okay, and after you do it the first time, it's going to be easier every time after. So please go ahead and write this code and see what happens. Okay, since we are here on this topic, I will just say to all of you that, of course, I have created a lab for you to practice, but there's a little bit more information on this lab, but here's the lab and the instructions, right? So if you go into this lab, this is only for Pandas now. This lab is for working on Pandas, okay? So there's two sections here. There's a first section, which is on the students' grades thing. I think you should more or less be able to do all of this. We're going to talk about Titanic actually in the next class. I will mention it today and then we'll go into some details next time. So if you want to defer this part, it's okay, but you can start on this, okay? So, okay, so let me go back here. Okay, so here we are back again. So we continue with Pandas, okay? We took a small detour to look at using it to explore some data. That specific data was in a database, but the database is not the important part of the discussion. the reason I use the same database is you can compare doing these problems, solving these problems using SQL versus using Pandas, and try to decide which one are you going to be more productive in. Okay. Okay, and if you really want to know how will you decide whether to do it in the database or in Pandas, then again you have to ask me the question, then I can spend some time on it. Okay, now let's continue. So the next idea we have is how do we delete data? Clearly we don't want to delete things, but once in a way you do want to delete things. So you can do drop, right? And you can pass in the labels and so on, right? Fairly intuitive. Drop has very similar semantics to what we would do with the index operator, right? You have to know what you want to delete. So once you do this, once you understand how to use the index operator. So spend some time practicing with that. If you want, we can come back and discuss drop more. Okay, you may not be doing a lot of drop, depends on the kind of data you have. Okay, this section is probably more interesting than drop. It's applying functions to databases, right? To data frames. So the way to apply functions to data frames is rather easy actually. If you want to do things by column, you can just extract a column. So for example, here for df1, actually here I didn't even do it by column. I did it. It's applied along the columns, but to each element. Okay, so actually to each element of the data frame, I'm applying this operation. Every element will be exponentiated, and then the log will be calculated. Let me ask a question. These two data frames which are here, they look identical. So did it work or did it not work? Somebody think there's a bug in Pandas or not? I applied two operations to the data frame. The data frame does not seem to have changed. Anyone? I'll give you 15 seconds. Does it look like the operation didn't work or it did the right thing? It's a trick question. Someone? Well, of course, I have to teach you one thing that's, at least here, I don't mind if you guess, okay? If you don't know the answer, you should guess. But can somebody try? Why did this data frame not change? Yes, I did log and exponential, right? So these are inverse operations of each other, so they will cancel each other out. Okay, just checking that you guys are awake. Okay, so yes, so yes, so at least Frank was awake. I'm sure the others are awake. They're just slow to type. But okay, let's keep going. So so now, for example, if you have your own custom function, ignore the fact that I made this a one-line function. Then to apply this function to every element of a data frame, you can use this command called apply map. And basically it will square every element of the data frame. Already you can see with these operations how powerful they can be, right? Because if you start writing for loops and all these things to do this, it's going to be a lot more code. What is cool here is that the code is one line or two lines. Use the right operation, we can get our work done quickly. So here is an example. You take a data frame and I want to compute the maximum and the minimum for each column, okay? So I say df1.apply, then I create this function. You can create it as a standalone function or you can use it as a lambda. Oops. And then you do compute xmin and xmax. Now let me try to explain this. This is kind of a cool little thing, but it takes a second to see how would this work. So how this works is that Pandas actually takes this function and calls it every time passing a column where x is sitting, right? So first it takes column A and it passes it into this lambda. And this lambda is calling the numpy function max on this whole column. And then this is calling function min on the whole column, right? And then subtracting the max and the min. So in one shot, you get this whole column-based operation done. Obviously, you can see it takes some time to get comfortable with thinking about solving problems using this technology, right? So here I did the max and the min by column. If I want to do it by row, then I use the axis concept, which we learned before. So I say apply this function, but not by the 0 axis, but by the other axis, right? By the row axis. So just play with this, use the axis, change your data. The task here is to compute the difference between the max and the min for each row and for each column. How could you do that? And the answer is, here's an example. It's a little bit of a toy example. There are some better examples where you could do this. For example, if you want to standardize, maybe this is I didn't give this as an exercise, but if you want to think about this example, if you have a bunch of data and you want to standardize all the data by column, right? So standardize means you subtract the mean, standardize, normalize, you would just subtract the mean and divide by the standard deviation. That would be a nice exercise to use apply and write the standardized function as a lambda, right? And then apply it to your data frame. Okay, so I can give you more exercises. I think I've given you plenty with the labs and everything, but if you want, I can give you more. But of course, you should create your own exercises. Okay, so as you're doing these examples, step back and think about how would I use it? Where would I use it? And if you can't see a way to use those ideas, ask me the question. And sometimes I might tell you, you know what, it's not the most important thing in the world, so don't worry. But apply, for example, is a very, very important concept. It's a transformation of your data. So it will be used all over the place, right? So apply in various forms. So 2 workhorses you're going to find. One I just briefly introduced is group by. Now I'm introducing you to apply. Then for all those who are following me closely, then we have to ask immediately the question, can we combine group by and apply? And the answer is yes, but we'll do that later. But that's how we get more and more complex functionality out of Pandas, okay? And of course, you can actually have it to do, when you do apply, in the previous examples, every time I did apply, I got only one value back, right? So xmax minus xmin is only one number. So that's why it looks like this. But if you want to actually get the xmin and the xmax for each column back, you can actually do it. And even you can set up the index to be the same as the values that are returned, right? So in this case, I'm getting min and max. So I set index equals min max, and look how beautifully I've got back my columns. And the rows are telling me what's the minimum value in this column, and the next row is telling me what's the maximum value in this column. Okay, so that I guess this example shows you in a compact way how you can use apply to do interesting things. For example, you can summarize all the properties of your data in a couple of lines of code. The next thing is sorting. Not too hard to do. I think maybe when you come up with good examples, we can discuss it more. But there is a sort. Usually sorting by index is a good idea. So you can say sort index ascending, true or false. And you can also sort along the axis. Okay, so if you want to sort the columns alphabetically or something, you can do it. But what might be more important than using the index is sorting by values. So you can say sort values, and then you have to say by equals, and you specify the column. Okay, you can notice here how powerful it gets. Suddenly you start with one sorting by values in one column, and now you can do multi-column sort. So if that's something you need to do, you can start playing with this and just get familiar with this, okay? Similarly, there's ranking function. So if you want to rank all the elements, you can just call rank and so on. So this would be a good moment for me to pause for a minute, see if there are any questions, and then I'm going to tell you what we do next. I'm not going to have, I'm going to save some of those things for next time, but I can give you a quick preview. So any questions? Okay, if there are no questions, how is it so far? Is it a lot of information? Is it easy? How does it look? At least give me some feedback. I'm waiting. Okay, at least someone finds it interesting. Is there another one who finds it interesting or useful? Okay, I got 2. I won't try to get everyone, okay? Put more on chat. I am carefully reading what you're saying, okay? So I have to ask this question. I do want you to understand that what I have tried to do for you is to try to put a narrative against what could be possibly tedious and painful, right? It's like a story. We started, so that story will help you to remember these things. The story is we started by knowing how to create stuff, then we started to find out how to access stuff by indexing, then we understood subsets, so on and so forth. So my whole, I don't want to repeat the whole story right now. I can, but I won't. And then the notebook saves that story for you to revisit. So I would really recommend for all of you to go through and do that story for yourself, right? Just go through the whole thing a couple of times, and then this will all get into your memory. Okay, with that said, now let me go to the next thing here. If you click on this thing called data analysis with Python, this is what we're going to do next time. But I don't mind sharing it with you. This notebook is a simple example for you of how to use pandas, but more importantly, the kind of thing you could do with your project. So I will tell you about it, but we won't run this notebook today, okay? So the idea was, I mean, all of you know about the Titanic, right? But this disaster has become a playground for data science. I don't know why. I think the first time I looked at data science, somebody gave me this data set as an example. So the idea is the following. You can take, so what is interesting is we have all kinds of information about the people who traveled on board the Titanic. If you want a refresher, you should probably watch the movie. I don't know whether you like it or not, but anyway, so there was a lot of people on board this ship, and we are trying to ask the question, is there a lot of people perished? And we can ask the question, is there some pattern in who died and who did not die? Right? So it's a kind of a good example for you of what you want to do in your project. Take a data set, start with a fairly simple question, right? Like this. And of course, the answer is unclear. If you haven't thought about it before, you're like, how am I supposed to say who's going to die and who's not going to die, right? But then as we analyze the data, and we'll do this together next time, we might start to get some ideas, right? And then it becomes more and more interesting as we start to recognize the patterns. Eventually, you can take it all the way to a predictive model, do some machine learning on this, and you can even predict. If you give me certain attributes of a passenger, I will tell you whether he was going to live or die, right? So it becomes a toy example of machine learning, right? But what I want to tell you is you don't have to necessarily build a machine learning model right away. The first thing is to look at the data and understand its properties and so on and so forth. So we'll do this notebook actually is an example of what could be your project, right? Take the data, do all kinds of analysis on it, etc. Okay, but you can browse it. If you have questions, ask me. But next time I will go through this notebook at least for half an hour. We'll go through it line by line. I'll make some parenthetical comments about how to use all the tools to analyze this data. And we'll be Pandas experts by the end of that, hopefully. Or not experts, at least proficient in it. So quick question for you. Does that sound like an interesting thing to do? Someone on chat? Okay, at least one person. One more person? Okay, so so then I think we will we'll wind up here. So at least a couple of you find this interesting. So we will wind up here. If any of you have other data sets you would like me to analyze or discuss in class, send me email, we can talk about it. But I also want you to start thinking along these lines to go and, what can I say, to think along these lines to go and start outlining your project. Okay, go find, so this is a simple example of what kind of data you can find and use. Okay, with that said, I think we are just on time, 2 minutes before the end of our session. So I will pause here. If you have any questions, I keep on pushing all of you to ask me questions. I think it's the best way of learning. So if you have any questions, either ask them now or send them to me in email. Please take some time to start working on your labs. Okay, I think it's really important. Don't look at the labs as a chore. Look at it as an opportunity to practice and become proficient. Okay, schedule fixed amount of time and just spend some time on it. If anyone has problems, send me emails with your problems and I'll help you either one-on-one by email, or we can set up a session somewhere where we can discuss it together. Okay, so I think we'll wind up here. Thank you so much. Keep up the good work. There's a lot of benefit to you if you can master these tools. So put in some effort and you can reap the rewards. Thank you very much. See you next week.